And we are live.
Ship it.
Welcome. I'm Ben Lauer alongside Rob Relier, and we're here coming to you live from the studio, and we're going to spend the day talking about the brand new, just shipping today, Kinect for Windows V2 sensor and the SDK and the robust platform that we have there. As you can see here on the opening slide, it's not just going to be Rob and myself today. One of us will be kind of co-hosting each module as we go through the day, but we're bringing in other experts from our team so that they can talk deeply about their area of expertise. So just a quick setting of expectations. The target audience for this content today is developers, creative coders, and interaction designers. The suggested prerequisites and supporting material, you're going to need to know something about programming. We're not going to teach you to code today, but you need some familiarity with C#, VB, JavaScript even, and then some familiarity with Visual Studio is going to be helpful as well, but not explicitly required. We've got 7 modules, so we've got 7 hours of content. Again, here in a moment, we're going to get into introducing Kinect development. Then the second module, we're going to get into data sources and programming model. We're then going to get into hand gestures, interactions, speech. Rob and Mark Swessinger on the team are going to handle that. Then after lunch, the first module back after lunch, we're going to get into using Kinect with other frameworks or libraries, things like Unity 3D, Open Frameworks, and Cinder. Matthew Samari is going to join us in Module 5 for Fusion Face and HD Face. Then Johan Marion will come in. He and Rob are going to talk about recording, playback, and gesture recognition. And then we're going to end the day with an advanced session. Casey Meekoff's going to come in and talk about skeletal filtering, skeletal tracking, and depth filtering. Rob, anything I missed there? What are you most excited about for today?
I want to see the demos in the Unity session.
Okay, cool. Great. So, again, now we're going to get into introducing Kinect development. The slides are available, actually, just as a quick aside. Quick shout out to our guy here in the studio, Danny. You're not going to see him, but he's back here. He's got this whole panel. It looks like the cockpit of a 747, all the things he's going to be keeping track of. His job is to help us make us look as good as we possibly can. I don't know how much he can do to help there.
He's working hard.
Yeah, he's working hard, so thanks to Danny in advance. Again, my name is Ben Lauer, and I'm the Developer Community Manager for Kinect for Windows. So that means it's all about events, developer content, programs, and whatnot. And then alongside me, I'm going to let Rob introduce himself.
Sure. Rob Relier. I'm a program manager. I focus on hand pointer gestures and interactions, but I love working with the community and talking about the great platform that we've got for you.
Okay, great. Awesome. Also, quick plug. We've got Carmen Siriano. We're actually going to see him later in Module 4, but he's our developer support engineer. He and a number of our Kinect for Windows MVPs are live in the chat room right now. So if you have questions, if something doesn't make sense as we're going along, post it to the live chat. Obviously, if you're watching the recording here, you're not going to be able to take advantage of the live chat. You can come to our developer support forums, of course, but post your questions in the live chat, and we're going to get those covered off as we go. So we're going to give a quick overview of Kinect. Then we're going to talk about the sensor. We're going to look at the features of the new V2 sensor, and we're going to look at the components of the sensor. I'm going to show you how to download and install the SDK. We're going to talk about Kinect data sources briefly.
Is it live? Is the SDK live?
The SDK is live as of, I don't know, moments ago. The preview SDK is live. We've got the URL. We're going to post that in just a second. Sensors are being sold and shipping right now, so it's a big day.
I've seen on Twitter some people are receiving sensors today. They're saying, hey, great sensor. Where's the SDK? Here you go.
SDK is up and available. We're going to get into high-level architecture of Kinect and creating apps. We're going to do a quick overview of the other 6 modules that are coming later today. We want people to kind of understand what they can look forward to. And then we're going to have a slide at the end with helpful resources and links. So let's jump in. So actually, this image that you see on the slide is actually the front of our retail box, which we have proudly displayed here. So you can pick one of those up if you don't have one already. So what makes Kinect unique? Well, it can see in 3D. So I think most people are familiar with, a webcam or a color camera or RGB camera, whatever you're going to call it. Kinect can see in 3D, so it makes it very unique. It does have that traditional video camera. It also has a 4-element microphone array. And that microphone array allows us to essentially pinpoint particular sounds in the room. We can pay attention to somebody over here versus over here. We'll talk more about that in a little bit. And then also our SDK allows you to know if a person is standing in front of the Kinect. We have all these algorithms in the SDK that can detect people. Also, we can use our skeletal tracking, or body tracking as it's now called in V2, to know what position a person's body is in, for example. The microphone, again, is controllable in software. We have speech recognition that you can do, so you can speech enable your applications. And there's lots more that you can do. And again, you're going to see that as we kind of go through the day here. So, Rob, why don't you talk about what's new? So I know you're excited about the SDK, so why don't you take us through this?
Sure. So the new sensor's shipping now. Do you want to show it now?
Yeah, I think we could do a quick, just a quick overview of the, what's in the box. This is the Kinect for Windows V2 sensor that we're looking at here. And we've got a nice long cable. If you look closely, this is the same connector that is used to plug a Kinect into the back of an Xbox One. So the problem with that is it doesn't plug into a PC, right? This is sort of a unique connector that's not readily available on a PC. So to remedy that, we've got the, thank you, Rob, we've got this hub that comes in the box, which accepts the Kinect connector here. And then we have power. So there's so much happening in the sensor, we actually require more power to run that microphone array and all of the sensors than what USB 3 can give us. So we have external power, and then we have this USB 3 cable. And then, of course, in the box, we've got the USB 3 cable, 2 meters long, and then we have this power supply and cable there. So again, that's what's in the box when you get a Kinect for Windows V2.
Available today.
Yeah, so if you don't have one or you need one, you can use this link that's on the screen.
So we're shipping the public preview today, the new V2 SDK, and it's available. We've got the URL here, aka.ms, K4W V2 Preview SDK. Go on up there. We're providing a great set of APIs that are available not only for desktop applications like the past, but also for store applications. And those same APIs are available and will work in the Xbox world as well. So you can build great Xbox applications once that comes along for you.
So then the other thing that we can do is, as Rob mentioned, you can connect and publish those apps. So this is the first time that developers will be able to publish a Kinect-enabled app to the Windows Store. So with the preview SDK that we have today, that's all available. You can start targeting WinRT and store apps, but actually publishing apps to the Windows Store won't open up until later this year when we actually have the final version of the SDK.
Sure, and we still support the desktop applications that you're used to, whether you're building native applications or managed applications, you still have full support there as well.
Right, right. And then the other thing that we're happy to announce is our team has been working in conjunction with the team over at Unity, and we're actually producing and publishing a Unity plugin or Unity package, if you will, and allows you to get all the Kinect data right into your Unity game or application. So let's talk for a moment about the use cases or usage scenarios that we've seen with the V1 version of Kinect for Windows. We've seen a lot of activity across these 5 areas, but there are definitely other places. One is in retail. So just a quick example of this. I could talk about this for probably the remainder of the module, but we've got a lot to cover. Retail, if you think about a large interactive display, again, you can have content going by, you can have ads, you can have videos, whatever it is, and then if a Kinect is there, it knows a person is present, You can then change your application. You can respond to that user input. You can have we've seen people use magic mirrors, interactive clothes, virtual clothes try-on, and things like that. Physical therapy, again, we have 25 skeleton joints on the sensor, through the SDK. So you can use those joints to then know what position a person's body is in, and we're seeing this used for physical therapy and the like. Healthcare, using Kinect as a way to monitor the patient room. Here you see it being used in the OR, what we call a dirty hand scenario, where people can gesture through information where you can't actually like use a touch screen or something else. We're seeing Kinect used a lot in education to make it more interactive, to supplement the existing curricula, and then also in training. So the image at the top is a partner. They're in the logistics business, and you always hear, I know when I was growing up, I always heard from my mom, like, lift with your legs, not with your back, right? And so it's really important for this company, for their employees to know how to lift things properly so they can train them using Kinect and give them feedback. So with that, actually, I'd like to take a quick look at a video. So if we could switch over to Rob's machine so we can take a look at that video.
What if there's no barrier between your brain and the computer?
When will my patients be able to just move or think and the computer just does?
What does it actually look like to put your sense of humor and your personality into your communication through your devices?
How can we improve people's lives?
The answer is...
we're doing it now.
It's happening now.
It's happening now.
At its core, Kinect technology is about humans. It was jaw-dropping the first time I saw it.
People get in front of it and they just light up.
You just think and move and things happen.
With Kinect for Windows, we can now do things that we could never do before.
The camera looks fantastic. The depth data is incredibly precise and crisp.
It is the best way to create animations. What used to take 30 minutes now takes 10 seconds.
With Kinect for Windows and Windows Modern Apps, we can get our software where patients need it the most, the home.
And it gives us access to the millions of consumers that are in the Windows Store, which is where we want to be.
Anybody can step forward and really shape the future.
As doctors, we're here to make lives better, and with these tools we can.
As a developer, Kinect for Windows has really made me look good. I'm a doer, and this technology allows me to do.
And there's just so much fun. Kind of magical.
Okay, great. So that was a couple of partners that you saw in there. We saw various applications in that video. Reflection Health showing off their physical therapy, and then Freakin' Genius showing off their Yakit application. Let's take a look at the sensor now. I want to look at the sensor features and the sensor components. So the sensor features, and a lot of this is in comparison to what we did on the V1 sensor. V1 sensor, amazing. Tons of things you can do with it. Actually, we saw some of them in the video. But in the V1 sensor, we had this motor at the bottom of the sensor. And there was actually an API, and you could adjust it up and down. It was kind of fun to play around with from a erector set robotics perspective. But that was there because the V1 sensor had a fairly limited vertical field of view. So with the V2 sensor, we have a much wider field of view vertically and horizontally. We've increased the depth fidelity by about 3 times. And we're going to show an example of this here in a few moments. The color camera is a full 1080p, so that's 1920 by 1080 resolution running at 30 frames per second. Lighting independent IR. We've changed the IR technology. In V1 we use structured light, and in V2 we have time of flight. And you're going to see an example of the really crystal clear, clean IR that we get. We've improved the microphones. And V1 we had 20 skeleton joints for 2 people being tracked at the same time. And now what we've done is we've actually upped that to 25 joints for all 6 people that can be seen at the same time. And then we've also done a better job with stability of the skeleton. We've positioned joints to be more anatomically correct. And again, we're going to show all this here in a moment. With that skeletal joint improvement that we've made, we've added thumb joint and a hand tip joint. We, of course, have hand states for open and closed. and then we've improved the range. So we can give you depth data as close as 50 centimeters to the device, all the way out to 8 meters. So this is actually an improvement that we've made, thanks in part to, maybe you want to mention this, Rob, we've had this developer preview program that we've had running since November.
Sure, the developer preview program, we've had people, thousands of people from a bunch of countries.
18 countries, actually.
18 countries,
yeah.
Thank you. Giving feedback and using early alpha bits since November. So they've given us lots of great feedback, and this is just one feature that came to be because of them.
Yeah, and you know, we'd always kind of, I think we wanted to do extended depth and have a better range, but it was really that preview audience that came to us and said, hey, these are the cool things we want to do with this, and really pushed us to get that implemented. So lots of things we could thank the preview folks for, but this is definitely one of them. So let's take a look at the components of the sensor now. This is just the front facade of the V2 sensor. And we're going to start off with power light. So this little light, when it's white, you know that the sensor is on. Now, one thing to point out is when you get your sensor out of the box brand new, it's going to need to have a firmware update done from the SDK. So when you get the SDK installed, everything's set, you plug the sensor in, and you're going to go into the, and I'll show this in a minute, but you go and run that sort of sample app to make sure it's working, you're most likely going to have nothing on the screen, and it can take anywhere from, I would say, 60 seconds to 90 seconds. But we have this service that's running on the machine all the time called Kinect Monitor. Actually, the Kinect Monitor makes sure the other services are still up, but we have kinectservice.exe. That's going to do the right thing, and it's going to look at the sensor, and it's going to say, hey, we've got newer firmware available, and it's going to push that automatically. So I'm not a patient person, so it's kind of hard for me to tell other people to be patient, but when you get the brand new sensor, just give it, like I said, 60, 90 seconds, let the firmware update happen, and then you should see that data start flowing into like IR basics or color basics or what have you.
That's a capability we didn't have in V1 at all. We didn't have the power to flash the firmware, so it's great that we do now to be able to update it.
That's right, that's right. So that's the power light. RGB camera, color camera is there on the left. We have the 4 microphones there. Don't take these arrows as indicative of the exact placement of those microphones. I'm just trying to show that that's where they are in that microphone bar. I want to do a quick shout out and thanks to our friends over at iFixit for letting us use one of their awesome images. Here's an image that they posted of a teardown that they did of the new Kinect V2 sensor, and just showing how you can actually see more things here on the inside. So there we're showing on both images the depth sensor and where that's sort of located. Then the IR emitters, we've got 3 IR emitters in there that are all sending out data in different times and different wavelengths and phases, again, to get that IR. So with this, I'm going to break into a couple of demos. So again, aka.ms/K4WV2 preview SDK. This will get you right over to this URL here. So when you click that link, you're going to get redirected here. You can take a look through install instructions, system requirements, details, and all of that. But basically, you want to click the big red download button. This is going to download a single executable. You run that, it'll install the runtime, it'll install the services on your machine. It'll also install our SDK browser that we want to do. We already talked about connecting the sensor. We kind of got ahead of ourselves there with the excitement. But the one thing, and Jesse Kaplan is going to talk about this more in his presentation in Module 2 about the sort of the suggested system requirements, but you must have a USB 3 port on your machine. There's so much data coming off of this new sensor that the USB 2 bandwidth just wasn't sufficient, so we're really using USB 3 here.
Yeah, with V1 we were already filling up the USB 2 pipe most of the way, and we've quadrupled the amount of color bits that we're sending every second.
Yep. So the other thing that I want to show here then is once we install the SDK, so here we are looking at the Windows Start screen. I'm just going to show what happens when you install the SDK. So as we come over here, you're going to see a bunch of things sort of light up. We've got Gesture Builder, which we're going to talk about later today. Kinect Studio, we're going to talk about both of those in Module 6. But you get this thing called the SDK browser, and I'm just going to go ahead and click and launch. So the SDK browser, is something that we had in V1. If you take a look here, we've got all these resources and samples. I can come in and I can look at different components. I can look at samples sorted by language. Here are the C# ones. I can look at only WinRT or Windows Store samples and so forth. So the cool thing here is there's actually a couple things. One, I can come in. So I was talking a second ago about how do I know that my sensor is actually working, right? I just plugged it in. I want to make sure everything's up and running. So let's just go ahead and run this infrared basics WPF sample. I can click run right here in the browser, and there we go. There's the application running, and you can see here, I can move over, I get closer. This is the IR image coming off of the sensor, right? So we know our sensor's working. I've got the power light on, I can see that. But the other thing I can do is, let's say I want to build a store application. Maybe I want to add Kinect V2 support to my existing store app even. Well, I want to know how that's done. So let's take a look here at the Infrared Basics XAML app. I can click install.
Now we can't run those store applications out of the box. We're not including pre-compiled binaries. So if you want to run them, you have to do this as well. But if you launch them in VS and compile and run, but Ben's going to show here how we install and modify the code.
Yes. Yes. So I clicked install. I just created a new directory here on my desktop called samples. I'm going to say OK. So you can see what happened. It copied this folder, Infrared Basics XAML. I can go in. This is the full application, full source code. So you can take this code, you can learn from it, you can use this as a starting point for your own application. So let me just open this. I'm going to double click the solution file and launch Visual Studio.
So Ben, you've been doing a bunch of codeathons lately. How many times are people starting from these samples? Is it common?
It's very common, and I think it really depends on the app and the team and whatnot, but it's very common. I mean, I can even share a personal example. I've got a side project. I'm building a Kinect-enabled photo booth, and I went in and I used the Color Basics XAML sample as my starting point, so I'm not having to like reinvent the wheel. I can use, it's well structured, and I can go in and then use that as a jumping off point.
So pick the sample that's most appropriate for what you're building.
Exactly, and I also want to say we're going to have more samples coming later this year when we finalize the SDK. We've got some others that we're still working on. So here, again, I can see all the code here. I can go in, I can take a look at mainpage.xaml.cs, which is where the code, all the interesting code happens. It's very well commented. I can see all of these variables that are created and used. I can come down and see, oh, I got to get a sensor as sort of my first thing. And I'm not going to go through this in detail. Jesse Kaplan, again, in Module 2 is going to do this. The point here is the SDK browser is just a really great resource for you to get in and show off, see how things are working, and again, get the code for those samples. So let's switch back over here to the deck. I think we covered everything, installing and running a sample, so we'll just move on to the next section here. So that brings us to Kinect Data Sources. And this slide, I'm just going to go ahead and do a build so we can see all of these kind of listed here. Rob, do you happen to recognize these guys?
Yeah, I do. Definitely. Team members, devs on our team.
Yep, and
call out to Patrick and Oscar.
Patrick and Oscar. Oscar's holding the team mascot, Winston, his dog, who's often in the office. But here's an example of the same frame that we captured and then represented here visually in sort of the various data sources. So I don't know how we listed this as audio. I'm going to go ahead and just fix this in real time because I think that's confusing. And
they were being very loud,
Yeah, they were being very loud. So the color image, again, 1920 by 1080. Very wide field of view. You can see them there. Infrared. We're putting out light into the space, and we're subtracting or removing ambient light from the scene. So this is just the light that we're putting out into the scene that you're seeing here. The depth information, again, we have all of those individual pixels as XYZ coordinate, so we know how far away things are. Body index is basically saying, hey, we recognize that there's a person or there are people here. So we see Patrick there in the green, and we see Oscar there in sort of the pinkish color. You notice that because Oscar's standing close to this chair, it thinks that the chair is part of him. So there's some things you can do to work around those types of things. And then the body is showing the skeletal joints or the body joints for each of the people who are detected there.
And we've got 25 of those now, and it's great to go ahead and run and check out the great fidelity that you get with V2 body tracking. See the thumb joint, see the fingertip, take a look at the increased stability. That's going to help your app.
And then audio, I don't know, do you hear that? Audio playing? We're not playing any audio. I just want to say we don't have the audio visualized here on screen, but again, we have the audio source coming off of the sensor. So I'm going to jump over to another sample here called Kinect Evolution. This sample is not currently in the SDK. It's sort of being finished up as we speak. It'll show up later in the SDK browser, again with full source code. But let's just jump over here to my start screen. So Kinect Evolution, it's built as a Windows Store application. And I'm going to stand up here, so maybe we can switch over to another camera. Let me unhook myself from the chair. And so what we're looking at there, again, right under the picture-in-picture, which is sort of covering up, we see the data source, the depth data. So you can see, my fingers are showing up here. You can see my mouth moving. You can see wrinkles in my shirt. You can probably even see the microphone line coming off of me. But again, very, very high level of fidelity in this depth information that we have. So the next thing I'm going to show is the infrared information, or the infrared source. If we were in the middle of a cave, I remember, Rob, I went camping one time as a kid, and we went to this cave in Kentucky, and it was so dark in there you couldn't even see your hand in front of your face. If we were there in that cave and we had this running, this is exactly what you would see, because this is only showing the light that the sensor is putting out.
Plus you'd see all the bats hanging right
oh
in your
man,
face,
yeah,
right?
that could be pretty creepy, right? You see all those eyeballs sort of lit up in the background. But again, super clean IR, great consistent source for you to use for object detection and recognition, computer vision type things. That's IR. Here's the color image. You can see, again, 1080p, very clear. But notice there's this light here. We're here in the studio, and this light's here to kind of light us up as we're seated. How sort of washed out my face looks. But that's the problem with color. Well, we have this other visualization here where, again, look at my head in IR. You see none of that additional light that's happening, whereas here in the color image that's inlaid, you see it. So this is, again, just showing how the IR technology in the Kinect sensor is removing that ambient light that's put out.
That's why recognition technologies like face tracking that we'll see later today from Matthew in Module 5, they're based on IR to find a great signal to detect those faces.
Right. So now let's take a look at the top left window, the skeleton. You can see here we've got, and first thing I'll point out is, you notice from my knees down there are these thin lines there. We actually tell you through the APIs confidence on the joints. So you can see here in the IR image again, or even in the color picture-in-picture, I'm behind this table. So my legs are occluded from the Kinect sensor. So what we do in the APIs is we say, hey, we think this is where the legs are, but again, we give you that data so you can know how confident you should be. But the first thing I'll point out is the stability of the skeleton. We've made dramatic improvements. The hips have been lowered to be anatomically correct, which allow us to really keep locked on and these sort of leans that you might have depending on your situation. We've added a clavicle joint, which allows us to do, shoulder shrugs and see those happening. And then as Rob pointed out earlier, we've got the two new joints on each hand. We've got the tip of the hand and the thumb, which we can then sort of see this crabby hand gesture as we see. So that's sort of the skeletal joints. Now, you notice these sort of globes around my hand. Well, these are showing our hand states. So open hand is represented by green. If I make a fist or I grip something, that's shown here with the red. And then we have this other hand state called the lasso, which is like two hands up. Not two hands up, 2 fingers up. And that's represented here by blue. So all these different hand states are available to you for up to 2 people that you would see. The last thing I want to show, actually, I have 2 more things to show. First thing I'll point out is in the bottom right corner, this is a visualization of the beam forming that's happening using the microarray. So if I come over here and I move to this side of the Kinect, you'll see that visualizer move over and indicate, hey, sound is coming from the left. Or if I move over here, or if I stop talking,
and I start talking from over here,
see, it now knows that the sound is coming from Rob. So this is, again, the advantage of having 4 mics. We can be very precise and know where those sounds are coming from. So the last thing I'll point out is what we call Blockman. Blockman is a visualization of the joint rotations that are present in the SDK. Now, what does that mean? Well, if I stand here and if I start to move my arms and I rotate my wrists, you can see Blockman is giving all of that data and showing those rotations. If I pick up a leg and I rotate my leg, you see that. So why would you use this? Well, if you were doing something, say, in Unity and you had a 3D character or avatar and you wanted to say, oh, I want to allow somebody to avatar or do character retargeting, you can wire up our model here to an external 3D model, like I said, in Unity, and you can make it very lifelike and realistic for people. So that's one example. So I got to make sure I don't get twisted up here in the thing. So Kinect Evolution, showing off the sources there again. So let's switch back over to the slides. So Rob, you want to talk a bit about the image sensors that we have?
Sure. We've got the color sensor, as you've seen, and it's, once again, 1080p, so that's 1920 by 1080. In V1, we had 640 by 480 is the best. We have you get that at 30 frames per second, 15 frames per second if light is low. The IR sensor.
Let's talk about that for a second. Why do we drop down to 15 FPS?
Just to make sure we get a good enough exposure.
So we're basically saying, like, hey, if the sensor detects a low light situation, we slow it down so that we can let more light in and give a better color exposure. Is that fair?
Absolutely.
Yeah.
And so, as Ben said, the IR sensor the size is 512 by 424. It's about 3 times you get 3 times the detail and the precision of the information within that resolution. Once again, Jesse's going to go deeper into these things, into the programming model and into the data model for these things in Module 2. This is 30 frames per second, just like color when it's running at its fastest. The body is pretty phenomenal, as Ben just demonstrated. The range.
Are you saying I have a good body?
Absolutely.
Or Kinect has a good body?
I'm sorry, that slipped out. So the body, we talked about depth range. The depth range is 0.5 meters to 8 meters. And the skeletal tracking, though, we want to make sure we give you great bodies, great joints when the range. So we make sure we limit it to 0.5 to 4.5 meters to make sure we give you great quality.
I think we should say that these body claims have not been evaluated by the FDA, and your results may vary.
Yep. So each body has a joints collection. It's got 25 different joints, and as Ben said earlier, we know if they're tracked or if they're inferred, and our visualizations handle them differently. Depending on how your code is handled, you may or may not want to treat inferred joints the same as tracked joints or whatever. But each joint has a position in 3D space. We give you up to 6 simultaneous bodies. Before in V1, we tracked 2 bodies at a time. We tracked 6 bodies, but we only gave you 20 detailed joints for 2 bodies at a time, and you had to rotate through them. We now give you all that information for the 6 simultaneous bodies, just like it's built on top of IR and depth, so it gives you the same frame rate of 30 frames per second. As Ben showed, he showed hand state, open, close, and lasso. And you have to steer that to 2 different bodies. The hand pointer gestures that we're going to talk about in Module 3 also relies on hand state to do interactions for scrolling, etc. And lean, body lean is a great thing as well that we expose. We expose the ability for you to understand we expose as a joystick would be exposed API-wise on Xbox, the lean of the body from side to side. So if you're leaning and trying to look around the corner of a visualization, a 3D visualization, you can understand that the user's leaning and you can steer the view and give them a great view there. So lots of great data to build great great applications that understand people and the room as well. Audio, so we have a great set of we have a great microphone array, and we basically have an audio beam that is steerable. It's automatically or manually, and usually it will go ahead and just go to whoever's speaking. But if you wanted to track a particular person or whatever, you're able to go ahead and steer that angle of audio as well. So lots of great stuff there. I want to make sure we have time to get through the future sessions that we're going to be doing as well.
Cool. Well, before we do that, why don't you take us quickly through this high-level architecture?
Sure. So we have a physical Kinect sensor, of course, and on top of that we have a software layer for the driver and a software layer for the runtime, and the runtime's job is to provide great sets of data in a dependable way. Jesse's going to talk about in Module 2 lots of different, the philosophy behind the runtime as well. As we've said before, there's a native API, a managed API, .NET API, and a WinRT API. They're flavored all the same, so if you're jumping back and forth, it should, they're identical, except for where languages don't allow them to be. But we've got one design for that API, allowing you to build great applications across the spectrum there. So once again, Jesse's going to go into both how to program against all those data feeds we just talked about, the data sources, and then the architecture in more detail as well.
Yeah, and one thing to point out is, unlike V1, in our V1 world, you could only ever have a single Kinect-enabled app running. So it was sort of like the first app to run got exclusive access to that sensor, right? But in this model, we have a shared model, so you can have multiple apps running, all using data at 30 FPS coming off of the shared sensor.
Yeah, you'll find that Jesse will talk a bunch about the startup code that we allow you to write now, and things like that have gotten simpler. So you have to do a lot less negotiating and handling errors of, hey, another app happened to run first.
Cool. So let's talk about the other modules briefly. So we talked a lot about what Jesse's going to talk about. Rob, why don't you talk about Module 3, since you and Mark are going to be running that one?
Sure. Mark Schlesinger and I are going to be talking about hand pointer gestures, including the interaction model, the programming model, and we're going to show examples of Controls Basics XAML and talk about Controls Basics WPF and Controls Basics DX. So you can across managed, across store, and across DirectX, you can have great buttons, scrolling, and other interactions built on top of that. And then we'll be diving into speech, showing how you can, both inside of an application, allow people to control content, or to be able to remote control, to do command and control on user interfaces as well. So
adding voice is another way to input into your application.
Absolutely.
Yeah. So just a quick pop quiz. How many lines of code would it take me, or sort of what's the level of effort if I wanted to Kinect enable my existing Windows Store app?
If you just wanted to do hand pointer gestures,
yeah,
it's about 5 lines of code.
Okay, awesome. That's really cool. Okay, so then Module 4, again, this will be our first session back after the lunch break. Carmen Siriano and I will be presenting this. Carmen's going to do a ton of demos. This photo here is of one of our colleagues named Rick Barazza, and he's showing in a Windows Store application, he's using a bunch of OpenGL shaders along with open frameworks to do that sort of nice blur effect on his right arm. He's doing that cool pixelation effect on his left hand. So we're going to talk about how do you harness the power of frameworks and libraries like OF, like Cinder, like Unity 3D, and get all of the magic of Kinect into those environments. So if you're new to creative coding, you definitely want to see that, because I think you'll be blown away at the types of things that you can do using shaders and the like in those libraries. So Module 5, Matthew Samari and I will be doing that module. Bottom left is Chris White. He's a PM on our team, showing him scanned with a Kinect using Kinect Fusion. So we're going to talk about how you can use a Kinect to scan people, objects, environments, and create a 3D mesh that can then be output to 3D modeling software or even sent to a 3D printer. So if we wanted to, we could have a little Chris White mini action figure. If we could send this to our MakerBot, we could 3D print that. Also, we're going to talk about face and HD face and how you can do face detection. You can know in which direction a person is looking. HD face is super cool. Tons, it's like 1,400-ish. Matt's the expert on this. Points that you can map on the face to get a really detailed face scan. Rob, you want to talk about this? The session you're doing with Johan?
Sure. Yeah, Johan, Marion, and I are going to talk about Kinect Studio, which allows you to record data from the Kinect sensor of as many different data sources as you'd like, and then do playback of that as well, which allows you to have great testing and you don't need to stand up quite as often. There's a bunch of great new features that we have in Kinect Studio that were not in V1. So that's going to be very exciting. We're also going to be showing off a great new tool called Gesture Builder. We're going to talk about how to do gesture detection, and we'll talk about two major approaches, one being heuristic or code-based, and then the other one being machine learning. And we've given that speech for a couple of years now, but we've just kind of said, oh, or you could do machine learning. We now have a set of tools and guidelines for you on how you can take those clips that you've recorded and tag them, and then machine learn a gesture, and then at runtime have your application run that and do the detection. So
very cool.
Great tool.
One of the things I'm most excited about in that session actually is showing people how you can use Kinect Studio to play back Kinect data without a sensor. This is something that was impossible in V1. You always had to have a sensor physically attached, and I can tell you, I take the bus home and to work, and so I love that productivity time where I can sit there with my Surface on my lap and be working. So with Kinect Studio, I can actually play these clips back, and I can be developing my Kinect app right there on the bus or on the plane or wherever you may be. Definitely don't recommend that you dev and drive, but anyway, I'm really excited to show people how that works, how you can basically dev without a sensor in some of those cases. So then the final session of the day is it's going to be really advanced. I don't want to scare you off, because I think if you're new to Kinect, you'll still get a ton out of this. You'll learn some different approaches. But Casey Meekoff is going to join me, and he's going to take us through skeletal tracking and depth filtering, talk about some interesting case studies, and just share some of the things that are, again, really, really great content there.
Yeah, Casey's in charge of our skeletal tracking team and depth tracking, and he's really a world-class expert on how applications and titles can take advantage of this great data to build great experiences. So it'll be a great talk.
Yeah, yes. Okay, so I think this is the last slide I'm going to put up, and then we're gonna open it up to taking some questions from the audience. But these are, I would say, the top resources that you should know about. One is just connectforwindows.com, general info. You can get to our blog. There's links to everything here, docs, downloads. If you want to go purchase a sensor, aka.ms/K4WV2 purchase. Available in 23 countries. Don't hold me to that. I think it's 23 countries right now. The Preview SDK, you can download it now, install it. K4WV2 Preview SDK. Developer forums. We've done something today. We have our existing forum that's focused on V1, but we have a new forum that we've just launched today focused on V2, so you can get to that K4WV2 forum. On Twitter, Our team's Twitter handle is Kinect Windows. You can get to me at Ben Lauer or Rob at @RRelier. We like to help people send, point them in the right direction, answer questions on Twitter if that's where you're comfortable hanging out. And then also I want to make a plug here. We've got 3 hackathons coming up. If you can make it to one of these events, I highly recommend it. There's a couple reasons. One, we're bringing our engineering team from Redmond to these events. Obviously, the Redmond event is easy for us because it's on our home turf here, but we're coming to Dallas. We're working with the group there to host this event, and we're going to be there in full force. If you want to get help with your app, if you're stuck, if you want to learn, if you want to take your app to the next level, come to these events. We'll be here in Redmond July 26th, Dallas July 18th, and then we're going to be up in the Waterloo region, which is just outside of Toronto, Ontario, up in Canada, the weekend of August 8th. So those are the links that you can use to go and register for those events. I'm going to leave this slide up.
And Ben, tell me about the format of those hackathons.
Oh, yeah,
Are people
sure.
working alone, or are they working in groups?
Typically we see people form teams. So if you've never been to a hackathon, typically the way they work is people get there, we mingle, we meet each other. People will get up and they'll pitch their idea. Hey, I want to build a Kinect-enabled photo booth that does X, Y, and Z, and I need help with foo, right, or whatever it is. And you'll see teams then organically kind of form, and they'll work as a team. But sometimes people will come in and they'll roll solo. And we just did a hackathon in New York last month, and we had some people come in solo, and they were there really to learn. So they just wanted to get exposure to the experts on the team. They were using that time to really work and say, hey, I'm going to get my machine set up. I'm going to install the SDK. I'm going to have the sensor. I'm going to start tinkering and really learn the platform. So we see all spectrums, but typically I think teams is kind of the norm. 3, 5 people is kind of what we typically see.
Gotcha. Cool. So we have some questions coming in.
Yeah, so looks like one of our questions that came in was about do we support multiple sensors and virtualization? So the answer on that is no. So let me answer that a little bit more. Virtualization, let's talk about that first. We require a DirectX 11 capable GPU for Kinect for Windows V2. None of the current hypervisor virtualization vendors support DX11. I believe DX9 is the latest that they support, so virtualization is not an option. Multiple sensors is not supported the way we did in V1. In V1, you could plug 4 or more sensors into a single PC. They each had to have their own USB controller. But we don't have that in V1. In V2. It's something that we're investigating and we're working on. But we've seen some workarounds from our preview program folks where they'll they'll have 4 PCs all with their own V2 sensor, and they'll send, say, the body or depth data over Ethernet, and then they can stitch it together on a single machine. And we've seen a couple different approaches that work for real-time and non-real-time. Our forums is a great place to get some suggestions if that's something that you want to look into. Virtualization, the other thing I want to say there is if, let's say you're running a Windows 7 machine, like maybe you have the required hardware, but you're not running Windows 8, you're running Windows 7. Or let's say you're running a Mac. You have a MacBook Pro or a MacBook Air, and you really want to get into Kinect. You can, on a Mac, run Boot Camp and run Windows there, but there's also this option called Windows to Go. You can take an external USB 3 hard drive that gets fully imaged with Windows 8 and Visual Studio and our SDK. You can plug that in, you can boot right from the boot screen, again on Windows 7 or your Mac even, and you can run everything off that external drive without impacting your main hard drive whatsoever.
So they also asked about porting efforts from V1 to V2. Now we've changed the API to take advantage of to expose the capabilities, the new advanced capabilities of the new sensor. So there are breaking API changes from V1 to V2. You probably are a better one to say how much time does it take?
It does vary. I mean, I've had people tell me, "Oh, hey, I ported it in a few hours," to it took us a day or 2. It really depends on the app and what you're doing. I think people who are moving from our managed APIs in V1 to managed APIs in V2 are going to have the easiest go, but it really depends. I would say the all-up thing is moving from V1 to V2, we haven't heard anyone in our preview program say, oh, it was this Herculean effort. We think it's relatively straightforward.
And Jesse will be talking to a bunch of the benefits that you get from the new API for componentization and other things. So
right.
We'll talk about that.
Right. So any other questions that have come in from the audience that we want to
Keep
take
those questions
here?
coming.
We're hearing in the back of the room that there's lots of questions, so keep them coming.
We don't have the majority of them. I've been giving you the ones that commonly come up.
Okay, so it sounds like we've been answering the questions. Our awesome MVPs and our technical support staff are answering those questions live in the chat. Again, if you're watching this video after the live event recorded, come to our developer forum. Again, let's put that slide back up so we can share those URLs with everyone. Developer forums at aka.ms/K4WV2 forum. So I think that might be the end of our first module, Rob.
Yep, great kickoff. We're
Anything
going to have
else
a
you
great
wanna share?
session. Order the sensor, download the SDK, and send us your questions.
Yeah, and stick around. I mean, I can't impress upon you enough how awesome these other modules are going to be with these other experts coming in. So stick around. We're going to take a quick break. Keep an eye on the timer if you're on the live event. We'll be back here in a few minutes from a break. So see you in a few.
Goodbye.